Welcome to my channel. Let's look at joints and how it is classified. Joint is a point where two or more bones meet. We have joints formed in different regions of the skeletal system. We have the humerus forming contact with the radius and the ulna in this region. So in this regard, we have contacts formed by three bones, which include the humerus, the radius, and the ulna. We also have joints at this distal region around the new joint. Also, we have joints formed where the head of the femur fits into the acetabulum, which is a region of the pelvis. It is called the hip joint. We also have another joint up here formed between the scapula and the clavicle. Also within the cranial region, we have joint forms within the patches of bones that forms the cranium. So we have joints formed in different regions of the skeletal system because the skeletal system as a whole is a collection of pieces of bones coming together to form a single large unit that is called the skeletal system. Basically, all the bones in the body form joints apart from one bone that is called the hyoid bone. The hyoid bone is seen at the roof of the neck, is formed just below the head region, and it is this bone that does not form contact with bones in the body. So it's like a standalone bone. The hyoid bone does not form joints with the other bones that form the skeletal system. So let's look at the functions of joints. We've said that joints are formed at different regions of the skeletal system, and they are constructed in such a way that they allow movement. So different regions of the body where we have these joints allow for movement at different grades and at different rates. They also provide mechanical support, and also they help to provide stability for the body. And of course, we know that pieces of bones will come together to form a larger unit that is called the skeletal system. And they cannot do this unless they are joined from one end to the other. And it is through the formation of joints that these bones come together to form the single unit that is called the skeletal system. And we know the skeletal system will provide the framework of the body onto which muscles and other structures lie upon to form the entire configuration of the human body structure. So classification of joints. How do we classify joints? Joints are classified on three bases. First is the structural classification. The structural classification is classified based on how they look, their morphology. Between the point where these two bones come in contact, what is the structure that is helping to hold them in place? And that is what the structural classification entails. Another form of classification is the functional classification. And functional classification from the name, which means the function that they can perform. And function of joint is attributed mainly to movement. So the grade of movement that they can exhibit will be used to classify them functionally. Then the third form of classification is biomechanical form of classification. And this classification is based on the number of articular surfaces that is seen at this joint. So let's go back to the structural classification, which means the morphology of the structure that allows this joint to be formed. So from structural classification, we have the fibrous type of joint, which means that at the point where these joints are created, we have fibrous tissue within this space that helps to connect these bones together at the region where the joint is formed. Then we have cartilaginous joints, which means that the cartilaginous joint will be joints where cartilages are used to connect the two bones together. Then we have the synovial joint, whereby the synovial apparatus are the structures that is seen within the point where these joints are made. So it is either we see in terms of structure, when we want to do structural classification of joints, whether it is a fibrous tissue, cartilaginous tissue, or a synovial tissue that is responsible for forming this joint will be used to classify the joint based on structure. Then going further on this, for the fibrous joint, we could either have sutures, we could syndesmosis or gymphosis. For sutures, are fibrous joint as we know, but are seen mainly in the cranial region. where patches of cranial bones come together to form the neurocranium. The syndesmoses are formed at the distal end of long bones, where the bones do not really form contact with each other, but are joined together by fibrous tissue. Then we have gomphoses, the last subclassification of the fibrous joint. And this is seen where the root of the tooth is inserted into the socket. And this is seen in the dental region, that's the teeth region. And that is where we have gomphoses, where fibrous tissue is used to connect the root of the tooth with the socket or the alveoli process that is created on the maxilla or the mandible. These are the subclasses of the different types of fibrous joints that we have. Then going to the cartilaginous joints, we could either have a primary cartilaginous joint, which is also referred to as C-chondrosis, or we have a secondary cartilaginous joint that is also referred to as symphysis. For the primary cartilaginous joints, they are joints that the joint space is seen with hyaline type of cartilage. And this type of joints are primary because the cartilage that is formed around the joint tends to ossify with age. So at the later stage, the cartilage is seen to have been transformed into bone. And this type of joint is seen mostly between the epiphysis and the diaphysis of long bones. So as development proceeds, the cartilage that is seen between the epiphysis and the diaphysis become transformed into bone. And for secondary type of cartilaginous joints, the cartilage that is seen within the joint space is still seen to be cartilaginous. And this type of joint are seen mostly along the median plane. And a very good example of this is the pubic symphysis. The next class of structural classification for joint is the synovial type of joint. For synovial joint, it means that this joint is seen with synovial apparatus, which include the synovial membrane and the synovial fluid. So within the joint capsule, we have synovial apparatus embedded within it. And this is the morphology of the joint that is created within this type of joints. So example of synovial type of joint, ball and socket type of joint that is seen in the shoulder region, or we have hinge type of joint that is seen in the elbow, Gladden joint, the condylar joint, saddle joint, or pivot joints. So these are the list of the subclasses of joints that we have under synovial type of joints. Then when we try to classify joints based on the function that they exhibit, that is the degree of movement that they exhibit, whether they exhibit little or no movement, or they exhibit slight movement, or even a wide range of movement. These are the basis onto which functional classification is done. We have the synarthrosis. For the synarthrosis type of joint, this joint exhibits little or no movement. An example of this type of joint are the sutures, the joint that is formed by the patches of bone in the cranium. Then we have amphiarthrosis. For the amphiarthrosis, they exhibit slight movement. And when you see this kind of joint in the cartilaginous joint, example, the pubic symphysis, then the diarthrosis exhibit wide range of movement. So they are able to move in different degree. An example of this type of joint is the synovial type of joint. A very good example could be the ball and socket joint. Then the last form of classification, which is the biomechanical form of classification. And this is the number of articular surfaces that the joint forms. And this could be uniaxial when the joints can run in just one pattern. And this includes the hinge joint, where the joint can move only in one direction. Then we have the biaxial joint, which means that they can run in two planes. An example of this type of joint is the carpal metacarpal joint of the thumb, where the thumb can move in two directions. The triaxial type of joint, which could also be referred to as the multiaxial type of joint. In this joint, movement is allowed in all directions. And a very good example of this is the ball and socket joint, which is seen in the shoulder region. So let's quickly look at the clinical application of joints. For clinical application of joints, the one we would look into is dislocation. This is a common occurrence, and it occurs as a result of displacement of the bones at joint. This is where the joint is created. The pelvic girdle is well fixed to the sacrum, but at this region, there's a form of dislocation whereby the girdle is displaced, is not place where it's supposed to, unlike this region. And major symptoms will include pain and also swellings around that region. A major treatment would include bracing or surgical repair. Let's check our understanding of this lecture through the following. Let's try to classify the following joints. We have the elbow joint, the parieto-occipital joint, that is the joint between the parietal bone and the occipital bone. These are joints within the neurocranium. Also the hip joint. Let's try and classify these joints based on their structure, the function, and also based on their biomechanical form. I'll be expecting your responses in the comment section. Please, let's meet in the comment section where we can drive more on this. So thanks for watching. Let's meet in our next lecture video.